Bismillahirrahmanirrahim. Assalamu alaikum and welcome to my channel. After this session of Lab 1, we have discussed how to make a code and how to implement it, upload it on Arduino IDE, Arduino Uno. We are working with Arduino Uno, and later in my coming videos, I would be also explaining about how to work with Arduino Mega. So this is a lab task 2. In this, what the condition was that if we have to store 30 and display it on the any port, and then we have to add 25 in that port, and then we have to clear the ports. So, first of all, the coding would be very easy. According to the coding, it would be a very easy task. You have to write a code on Arduino IDE, and that's a very simple task. With according to it, I have also added a delay function. If you do not want to, you cannot even add a delay function as well. So let's go to the coding and see how it works. I've already created it, so I would be going on it else and explaining it. So first of all, I'm sorry for this disturbance. First of all, as you can see, that we have written .org .0, then start, and then we have written LDI. LDI, now what is LDI? LDI is a condition to when you want to initialize, or you want to implement one of any of the code, any of the resistors, or any of the LEDs or anything inside it, inside the assembly language coding, you must be writing this command. So after the LTA code, we have declared resistor 16, and we have initialized its value as 0 cross FF. Now, what is 0 cross FF and what is 0 cross 00? Now, whenever you declare anything that is 0 cross FF, it means that all the bits are 1, and this means it's an output bit and in output bits. And if you declare that any kind of port or resistor 0 cos 0 is any kind of port with 0 cos 0, this means all the bits are 0, and this means it is an input bit, and input bits, it has input bits and all of it, and you can add any kind of value on it. Then after that we have LDI R60. We have what we have done, that we have out then out R6 R DDRB. Now DDRB gives the direction to a port, and that's why we have given the direction to out DDRB to R18. R18 is the resistor number 18 that we had initially initialized before, that with the 0 cross FF. In my code, I have initialized with 0 cross 6 is 1 6, that means R16, and we had already explained its value as initialized its value as 0 cross FF. So afterwards, that if when I stored its value of 0 in our DDRB, this tells that the port B has been implemented into um, output an output register of output port, and then we have then again we store a 30 value in R16, and we out in an R port B. This means that now the command has given that R16 value, then 30 value is declared from the R16, declared from port B, and it would be displayed over here in my Proteus tunnel over here. And then after that, what we have done, we have called it delay of a delay function is detailed written over here. We have simply initialized three resistors, and they have their value is 220 20 20 25 to 2 to 5 2 to 5 2 to 5 2 to 5. This means the highest bit of values, a highest bit of value. And then we have used vrne. This is a command that we use where we want to the loop should end only until and unless the value of the resistor turns into 0. And after that, we have created one loop. In this first loop, we initialize the value of R16 of uh, uh, of R16 R17 value as 25. Now first we in R16 we had stored the value of 30. Now in R17 we would be storing the value of the 25, and after the 25 value, what we would be doing, that we would be adding into resistor, um adding into resistor 16, that was R30, that was 30 as we initialized it before. And this would be done by using add command and R16 comma R17. By this the value of R17 is added into R16. Now R16 is the sum of the R16 and R17 value, and then we would again output it on port B. And then what we would be doing, we would calling again delay, and then we would be clearing R16 by CLR command. Now let's see its hardware video. Now see over here, the first it was R30 was displayed, now R25 is displayed, and now the sum was displayed, and now it is again cleared, and it was again implemented to R30. R30 30 value. This was the sum of them. So this is the 30th value. And it is also working on Proteus. As you can see, we simply it would be first it was going this, and then you can see it is converting to. Then the number task two, we have to take the code from, we have take the input from one port and display it in the output port. There is nothing that is changed much in complex in it. There is only one thing that has been included in it, and I would be explaining that as well. So this one thing was that we have in this one, we would be just doing one thing. We would be taking our DDRD as input, and we would be declaring our 60 we have LTR R16 as 00. This means that it is an the R16 by the in R16 0 cross S00 is saved. Then we declare DDRD DDRB as R6 with stored R617's value in DDRB. This means it is input port because all the ports are 0. Then we have input from R617 and pin B. This is the syntax to write on it in assembly language. Then we have then created another register that has all 0 cross FF and stored in D port. So this means that D port is output port. And what we will do that we would report out port D R17. Now R17 value displaying the output port on port D, and then clear resistance R17. There's a little bit of mistake over here. This would be port D, and port D R17. R17 value was stored from whatever the pin B had. So this is there's a mistake, and it I would be clearing it out. But this was it, and let's see ahead that how it is implemented. From in the Proteus, we just add one switches at one side and the entities at the other side, and as so whatever switch we open, the that LED would be on, like over here. As you can see, I'm starting to opening to connect the switch, and as soon as I'm connecting the switch, whichever the switch I'm connecting, it the LED is opening up, and similarly the next LED is also on. Now the third function, that is charging sequence of LED. Charging sequence of LED you have already many times seen in your in your compute in your laptops, this LEDs, laptop LEDs, and many of the other places. So here is one of the coding scenarios that we would be using in order to perform it. So first of all, what I've done is I've simply declared our DDR port D as output. And what I've done is I have initialized its binary values. First one bit was on, then 2 bits are on, then 3 bits are on, then 4 bits are on, and as I was doing this code on Arduino Uno, so this was implemented correctly. And now let's see it's um, working over here. As you can see, first bit, the second, then third, then fourth, then fifth, and then sixth, and then seventh, and similarly, this would be including in more head. Now, the next fourth task, that fourth task is to compare the values and the different port. Now, what is the compare value? That we would the syntax of everything would be remain the same. Just what would be changed is that um okay, so what I've done is that first I had declared R16 as input, and then DDRB is given the direction, DDRC is given the direction. That means both the ports A, B, and C are considered it. Now, because we have to compare two ports, so these both ports are considered the inputs, and then but I've considered DDRD means the D port as the output. Now, input is taken from port B and port C, and their value is stored in R17 and R18 respectively. Then we have use CP command, that is compare command, and this then we have VR equal, that unless and until they are equal, if they are this function would not be performed. This function is if unless and until they are equal, this equal the loop will not be jumped to equal. Otherwise, it will simply go to LDI R16 and this value would be formed. But when as soon as this would be equal, this label would be turned high, and this would implement over here. And as soon this R16 value would be implemented. So let's see, it's hardware. Simply gonna play it, and look, as soon as the button is on, this means on the LED R16 is high and R17 is high and R18 is low. So that is why it was it was performing toggle. Then this is traffic light signals. The traffic light signals. Now, how the traffic light signals were working? So we would simply go to the traffic light signals, and I'll be explaining it detailing. Now, this was my traffic light signal code. Now, what happened in the traffic light signal code was that after I first declared all of them as whichever output, the port C is output and port B is output. Now, what happened the next was that when 0 means this was yellow light. When yellow light was on and others are red, and then others are on, and this then just like this, I've used binary values and call delays, and by this I've performed this traffic light code. Traffic light uh, signals is working over here of mine. As you can see that it is working with, as soon as the one is going to turn on, it waits for a second of yellow light, and then it turns to a green light. So this is the working code. Now let's see how it is working on the hardware. So this is working like this is on, then this is on, and then this, like just like this. It is going from one bit to another bit. Thank you very much. If you like the video, please like it. Thank you so much.